In this section, we look at angles and circular rotation. So we're going to start talking about pieces of a circle, and I'm going to start counting here. Eventually, we'll look at the circle on an axis, and so this would be the part of the positive x-axis. So that's why we tend to start here. And all the way around a circle, one turn around the circle, this is rotation. So one turn is 360 degrees. Okay. Well, that means that 1 degree is 1/360th of a rotation. 1/360th. So let's look and see what part of the circle we have with other rotations. If I want to go 1/8 of a circle, I'll do that over here, 1/8. 1/8 of the whole thing would be 1/8 of 360, which gives us 45 degrees. So if I start here and I do 1/8, I would have a 45-degree angle, which would end about here. And I'm starting at this point and moving in that direction. I'm moving counterclockwise for my rotations. So this angle is 45 degrees. How about if I go 1/3 of the way around? If I do 1/3 of the way around one rotation, 1/3 would be 120 degrees. So I have to keep going 1/3 of the way. I divide this into from there to there to there. 1/3 of the way around would give me about over here. About like that. So this would be the angle from here up to here would be 120 degrees because it is 1/3 of the way around the circle. So 180 degrees. How far around is that? Well, 180 is part of 360, so I go 180 divided by 360, and that will give me a half. So 180 is half the way around the circle. So I get over here, and I have this whole piece over here gives me 180 degrees. Let's think of one more. 270 degrees. 270 divided by 360. Now, I suspect you just take the calculator and divide. And if you do that, you would get 0.75. But we tend to think of these in terms of fractions because it's a pie. See? That's very nicely divided into pieces for a pie. And 0.75 is 3/4. So 3/4 of the way around the circle, which if you divide the top by 9, you get a 3, and the bottom by 9, you get a 4. So 3/4 of the way around means we've gone all the way around, covered all of this, down to there. So 3/4 of the way around means that that angle as it goes around like that here is 270 degrees. So this big angle is 270 degrees. And then you'd have another 90 degrees left to complete the 360-degree rotation. So to get a feel of portions of a circle and the degrees that go with it. So you'll be using a lot of these, and it kind of helps if you have an idea of where they go, which you probably do. In this circle, we have an angle drawn, and it cuts off this arc, and we want to figure out the degrees of an angle, but we don't really know if it's the angle in here or the big angle out here. Now, if we want to determine it, we can see that we have 6 dots on the circle, and they are equally spaced. And if they're not exactly, pretend like they are. And I'm going to start labeling here number 1 so that we can, usually we start our angles at 1 at this position. So that would be 1, 2, 3, 4, 5, 6. I have 6 arcs in my circle. Now, this is cutting off 1 arc, or it's cutting off out 5 arcs. I want to know the angle measure of 4 to C to 5. And that could be, like I said, 4 to C to 5 in here, or 4 to C to 5 out here. So let's find them both and see what we've got. Now, since it just went from 4 to 5, and I do have 6 arcs, I'd have 1/6 of the circle. So 1/6 of my 360 degrees would be 60 degrees. So that looks like it might be. But this would be the angle in here, is 60 degrees. What about the outside? Well, there are a couple ways you can think about this. You could go, well, I could say if I take away 60, what's left is 300 degrees. So that this arc out here is 300 degrees. Or, depending on where you are and what that number is, what I have left, 1, 2, 3, 4, are 5, and I take 5/6 of my 360 degrees. And again, when you either multiply 360 out and divide by 6, or go from this, you get 300 degrees as the larger arc. There's only one correct answer, and you'll never have a possibility of both of these being the answer to a question. If you're asked for an angle, it could be either one of these, but you won't be given both as an answer. And so that does help a little bit to kind of figure out what you have to do. Just do one, figure out the other, and look for your answer. Here we want to look at the initial and terminal sides of angles that are in standard position. Standard position means that the initial side is on the positive x-axis. That's where we very first started talking about our angles with circular rotation. We started them on what has now become the positive x-axis. So if I want to find the initial side and the terminal side of an angle of 240 degrees. Now, we also saw earlier that halfway around, let's say I'm going to start here, halfway around got us to 180 degrees. So after 180 degrees, I have about another 60 degrees to go. So another 60 degrees. Down here, we also saw we had 270 degrees. So 240 is somewhere in the middle here. 60 degrees from 180 and only 30 degrees from 270. So the terminal side is the side where the angle ends. So the terminal side would be here if our initial side is here on the positive x-axis, and we rotate here. So our rotation gets us to here as the initial side, and then the terminal side for a 240 degree angle. Now, something we've not really looked at, suppose I have an angle of negative 60 degrees. Positive angles go this direction, counterclockwise. Negative angles go clockwise. So when we start with our initial side on the x-axis, if I want negative 60 degrees, it has to go in the opposite direction. And the terminal side would be here for an angle of negative 60 degrees. So this angle, let me put it in a little bit different place, is negative 60 degrees. And this angle is a positive 240 degrees. So the initial side will always be on the positive x-axis. Positive angles go counterclockwise, negative angles go clockwise. And you put your terminal sides wherever they need to be. Here we have the Ferris wheel problem that you'll see a couple of times in the lessons. This Ferris wheel loads at the 3 o'clock platform, and so the loading platform is over here at the 3 o'clock side, if you're thinking about a clock, not digital. This is your cart you're sitting in, so you load there and you start there. This says graph the initial and terminal sides. So this would be the initial side of your angle, standard position. Now, it stops for repairs after 29/8 revolutions. So it's going around and it's going around and it stops. So you're stuck there for a couple of hours. We need to find the terminal side since I gave you the initial side. Now that 29/8, you go all the way around several times because this is bigger than 1. So you don't just go part way around. You could have gone around 3/8 or 7/8, but this is 29/8. Now, I suspect you'll use a calculator. 8 goes into 29 3 times, so it'll be 3 point something. I like to work with the fraction things, so it'll be 5/8. You're welcome to do that with a calculator to see how far around you go. However, you have to watch for estimating decimals. Use lots of decimal places. I'm going to stick with fractions for this example. Now, this says we went around 3 times. So it started off here and you went around once, twice, 3 times, and what's left is 5/8 of your circle. A whole circle is 360 degrees. So you went all the way around 5/8. Now, for this one, 5/8 is a fraction that ends. It's only got 3 decimal places, so you don't have to round. Multiply it by 360 degrees, and you end up with 225 degrees exactly, whether you do decimals or fractions. So where is 225 degrees on our circle as we do our rotation? We get back here after 3, and we go, I always think in terms of 180 is over here, and 180 from that is 45. And so I've gone about halfway down to the bottom. So this would be the initial side of my angle, and this would be the terminal side. And we've gone all the way around 3 times plus there. So you're almost to the bottom. You could almost get out and climb on the scaffolding and get down, like in a movie. But this is how you'd figure out where you're going. But you may use decimals, we'll talk about rounding a little bit later. Now in this section, we're orienting our angles again on the x-axis, and it's important for you to know exactly the angles on the coordinate axes. We've already talked about our initial sides starting here, so that would give us a 0-degree angle on the x-axis. And as we move up here, we're 1/4 of the way around. So our y-axis, the angle from here up to the y-axis, is 90 degrees because that's 1/4 of 360. Halfway around, we've seen is 180 degrees. 3/4 of the way around is 270 degrees. And if you want a whole complete 360-degree angle, that's the same as 0. The initial and terminal sides connect. And so these are the angles that are on the axes. And we mostly looked at nice round numbers, 45 degrees, 60 degrees, -60, 240. How about an angle of 153 degrees? This is not on an axis. But if you know the angles that are on the axes, then you know how to position these. 153, okay, 153 is bigger than 90 and less than 180, so it's in here somewhere. You could be exact, it's what, 63 more than 90 and less than this, so it's closer to the 180. So we'll consider this angle to be our 153-degree angle. How about a 637 degree angle. Now, all the way around once is 360. Have we gone around twice? Well, let's subtract 360 from this. 277 degrees. So I went around once, all the way around once, and then I'm coming back 277, a little over 270. So that the angle here, that the initial side went around twice, then it comes back to this position after I go around, I come back here. This angle from here to here is 270 degrees. The 637 just means we went around one whole time and did part of another time. So let's look at another example that's an application. Well, here we are on the Ferris wheel again. Board at the 3 o'clock position over here. This is where we board. Ride 4 complete turns, and then it stops after we've gone all the way to the negative y-axis. This is why I drew the axes this time, because we have to go to the negative y-axis, which is down here. So we go around 4 times, and then go all the way around and stop down here. So this is where we're stopping for this problem, right here. We know, since this is about the axes on the angles on the axes, that this angle down here should be 270 degrees. So how far did we completely travel from start to finish? Well, if we went around 4 complete turns, that was 4 times 360 degrees. And then the last time our angle is 270 degrees. So multiply this, I get 1440, add 270. So my entire angle is 1,710 degrees all the way around. Now, we had a neighboring cart. The neighboring cart, of course, they didn't travel quite the same. I suppose they traveled the same distance as we did. No, because they weren't on it as long as we were. Huh, okay. Suppose there's a neighboring cart. We'll worry about the time logistics later. And this cart traveled only 2 1/5 revolutions. Turns. Turns, revolutions. I can fit turns in here. Okay. So suppose that here, what's their angle? 2 times around, 2 times 360, plus 1/5 of the turn. Well, we've done the fractions before, 1/5 of 360. So I have to add all this together. My 2 times this is 720, plus 1/5 of this, or 360 divided by 5 gives you 72. So they traveled 792 degrees. So remember that if you have a big amount, for example, if I started with 1710, I'd have to subtract my turns to figure out where I ended. And here, for 2 1/5 turns, I would have to do pieces to get my degrees. So just read carefully where you start, where you end, and exactly what the question is asking you to find.